Hello, everyone. We have quite an interesting question for us to discuss, and it goes as follows. A piece of copper of mass 20 grams at a temperature of 110 degrees Celsius was dropped into a mixture of ice and water at 0 degrees Celsius. If the final steady temperature of the mixture is 0 degrees Celsius, calculate the amount of ice that melted. Given that the specific capacity of copper Cu 0.4 joules per gram per Kelvin, and the specific latent heat of fusion of ice LF subscript ice 330 joules per gram. Options A 0.37 grams, B 0.60 grams, C 2.40 grams, and D 2.70 grams. On looking at this question, this is method of mixtures, but the truth is we can easily say that the hot body here is the hot copper. Copper is a hot body, while the cold body here we have cold water and ice. Okay, so let's bring out the parameters for the hot body. So the hot body, the mass M1 is 20 grams. Okay, the temperature T1 is 110 degrees Celsius. All right, what else did they say? Okay, that's it. Then they now say was dropped into a mixture of ice and water at 0 degrees Celsius. So that means that the temperature here for water, the temperature of water T2 is 0 degrees Celsius. Okay, that of ice still the same, T3 still the same 0 degrees Celsius. Okay, then what else? The final temperature of mixture. So let me call this temperature of mixture T is 0 degrees Celsius. All right, what else? What else? They say calculate the amount of the ice melted. So we are looking for M3. That is mass of ice. Okay. Although here they gave us specific latent heat of fusion of ice to be equal to 320. Copper, the specific capacity C1 is 0.4. Okay, I'm just ignoring the unit. So here, truth be told, according to principle of conservation of heat energy, the total energy lost by the hot body equals that gained by the cold bodies, which are water and ice. So the heat lost by the hot body, which is copper Q1, is equal to M1 C1 delta T1. Okay, so which is M1 is 20, C1 is 0.4, then it will be 110 minus 0. Okay, which will still leave us at 110. So if we multiply this, it will give us 880 joules. So here we have 880 joules. Okay, then for the water, you see that the final temperature of mixture and that of water is the same thing. So whatever we do here, the amount of heat here will be 0 joules. So here, Q2 is automatically 0 joules. How do I know? Because the final temperature of mixture is 0. This is 0. If you take the difference, it still remains 0. Then T3, Q3, that is the heat gained by ice at melting. It will be M3 LF3. Okay, which would be equal to the mass, which is unknown, times the latent heat of fusion, which is 330. Okay, so in the end, we can now come to conclude, according to the principle of conservation of heat energy, that finally, I'll be using, let me create a space here. Okay, finally, we'll have it that 330 M3 is equal to 880. All right, so M3 will be equal to 880 divided by 330. What came about this? Because the total amount of heat lost by the hot copper is equal to that gained by the cold body. So if we work this out, we'll be getting 2.70 grams as our final answer. And that leaves us with option D as our final answer. Thank you for watching. Remember to like, share, and subscribe to our channel.